Hey there, School of Tomorrow students. We're just loading up Jupyter notebooks. What I'm going to talk about today is sort of the namespace idea. In computer science and Python, it's very strong, but with regard to synergetics, I'm saying you got to learn where to put a frame around it. And that's hard in that you're talking about a whole world view, right? And I just last night let this play. It was a 3 hour lecture, the so called Bartlett lecture. Was it in Canada? It's very well introduced. It's a packed audience and three straight hours of talking. Somewhere towards the end, he does what I think is a maddening thing for a lot of listeners, is he exhorts us to, as a planet, become a star. Become a star. Don't just be like a student, become a teacher, kind of. We're intake now, tomorrow. He's got this exhortation language that, in my view, is grading, right? Because we know that planets don't become stars. We know from our current astronomy, and that's got a lot of gravitas. We feel a lot of strength in that worldview that, stars are a fusion thing and they're a disaster for life. Now, or water in particular, you can't have a water star. So, what is he saying? If we become a star, what? We should explode? So, obviously, he's using a weird namespace. And as I've talked about in earlier videos here, let's go to the source of it all. I kind of make this just because of the resources down the right side, I make this be the portal. And I want to go to Synergetics itself. And I always go in through the figure index, which is kind of a back door. It's like usually what I'm after is kind of a right brain thing. So I go in through the back door, but I have immediate access to the index. And here I can go to any topic in the book itself, outside the figures. And I can use my search function and remoteness. I'm looking for remoteness of the synergetics vocabulary, and it doesn't say if it's about the vocabulary here. Let's try a different approach. Let's go to V and try vocabulary. Now, Ed Applewhite made this index, and volume 1 did not have the index, so it's good that we got both volumes. Vocabulary is not here. All right, so I'm going to go back to remoteness. What I want to drive is, I don't think, for example, that the concentric hierarchy that I talk about all the time has to, quote, mean something in terms of particle physics or anything else. It's a freestanding sculpture. And what I want to show you, or a piece of logic, like we can use this in the philosophy of mathematics, synergetics, just to study what does it mean to make sense. And we can start with the concentric hierarchy in a vacuum, as I like to call it. And for example, one of the things we're studying, David Koski and I, is the so-called mystery shape that occurs mathematically. I mean, it's not difficult arithmetic, but we're discovering things about it in terms of its volume, how it could be related to other volumes, and that would be in the Jupyter lab. Let's go to documents. So you'll have your own tree. This is what we call your personal workspace. It doesn't have to look just like this, obviously, but what I talk about in this channel is I think school means equipping you with this kind of a surrounding. If you're going from room to room, desk to desk, and you got a locker somewhere, that can work for a lot of things. And I've been involved in that whole process myself. I've been a high school teacher. I've done after school programming a lot. So I appreciate people being together and so on. But you want a place that we can call your personal workspace. And you notice everyone who's making YouTubes and stuff seems to have something like that. And you might be thinking, gee, if only I had those kind of advantages, I could do something like that too. And I'm agreeing with you. I'm agreeing with you. I'm saying this is what school is. It's providing a personal workspace, and that doesn't mean all school is remote or something. It means you need to be available to other people who want to contact you remotely from their place, right? Basically, you need to have the equivalent of a cell phone, but with pictures, but with moving pictures, but with computation. In other words, a real computer, something with a display. You know, a cell phone is just too small to cram all this, I think. So the S module is this whole shape that you can carve out from the space between the volume 4 octahedron and the embedded icosahedron. Volume 4 icosahedron, volume 4 octahedron right there, and you've got face flush, an icosahedron with faces flush. So that is the shape. But we have icosahedrons like we have rhombic tricontahedrons and other such wireframes appearing at different volume levels. Like, you know, they get bigger and smaller. So I'll talk about the super RT, and that's the rhombic tricontahedron in which the jitterbug icosahedron is embedded as face diagonals, long face diagonals, right? Just like the long face diagonals of the rhombic dodecahedron, the long face diagonals of this guy creates an octahedron. The short diagonals create what? A cube, right? This. So same idea with the rhombic tricontahedron. You can trace the pentagonal dodecahedron and the icosahedron inside it. Now what if you take that rhombic tricontahedron, the super RT, and subtract what I call the jitterbug icosa, which has edges 2 and volume about 18.51 tetravolumes? Well, what David Koski is finding is, didn't mean to leave that page, that particular volume, the difference between those two is equal to what we're calling the mystery shape in terms of volumes. So scrolling down to these very recent computations that I've tacked on to the end, there we go. So the super RT, which is about 21.21, minus the jitterbug icosahedron, about 18.51. That's volume 1, we'll call it. Volume 2 is, I'm going to take that octahedron of volume 4 and subtract the 24 S modules. So that gives me the icosahedron that's faces flush. And then I apply the S factor, 1 over the S factor actually. And that we think, we think we have a good animation for that, a good cartoon for what that looks like. Because when you apply this 1 over the S factor a second time, that gets you down to the cube octahedron with faces flush to the same octahedron. In other words, the octahedron and cube octahedron have a nested relationship where you can put one inside the other. I'm just scrolling up to see if I can find a good picture of that. So you get the idea. Those are the same volume as what we're saying. That difference that I described at the beginning and the 1 over the S factor. So here we're going the other direction. Start with 2.5, which is the volume of the edge 1 cube octahedron. Multiply it by S factor, which is 1.08 thereabouts, twice. So we're going up the ladder in terms of volume, bigger and bigger. And we get what I call icosahedron within. That's the one inside the octahedron with volume 4, this guy right here. Now you can see in this same picture, if you look carefully, that the cube octahedron I'm talking about, the 2.5, is also outlined. Very hard to see, but there is a cube octahedron. This is figure, let's see, what figure is this in Synergetics? 988, if you want to go look at it. Over here, actually, easier to see. This triangle that's actually dividing the face into equilateral triangles, 4 of them. You can see where my finger is pointing. That's the face of the cube octahedron of volume 2.5. The outer octahedron has volume 4, and this icosahedron screwed, didn't mean screwed, skewed, you could say screwed, inside, inscribed therein, faces flush. That's our 2.91, which I call the icosahedron within. Okay? So going back then just halfway from the 2.91, go back one stop towards the cube octahedron, because this was two applications of the S factor. Between the 2.5 and the icosahedron within, there's one station stop in between. Like the first station stop is like halfway in between, you could say, more or less. And I think we just keep sliding along the rails. In other words, just take that triangle that's inside this one, a cube octahedron's triangle, and just keep sliding all the points towards an opposite vertex. So the internal triangle gets bigger. And somewhere in between the two shown is going to be the intermediate volume that we've been talking about. And its volume is going to be the same as the super RT minus that of the inscribed icosa. The difference there, so back to the calculations at the bottom, the difference there, look how little the difference is, and that's rounding error clearly. Now I'm using super high precision computations, whereas David is using actual modules, analysis of E and S and phi scale and this kind of stuff. So I'm verifying what he's telling me over the phone, right? And he's deriving these results by his own process. There we go, volume 2, which is the way station, the stop point, the mystery shape, times one more down, gets us to the 2.5. And you can see, as close as we want to get, that's computing to 200 decimal places. So we're using extended precision again, or arbitrary precision floating point, which is one of the things I like to showcase in this work. So that's, a deep dive actually into the concentric hierarchy, and I'm saying none of that has to mean anything in terms of physics for it to sit there making sense and sort of radiating intelligence in its own way. And that's all I require. It's like glass bead game. I'll end on that. When we were talking with Mario Livio that time, came to Portland, Oregon, to the Pauling House, and I was getting my coffee shops network off the ground. I would say I like to read Love's Body or Assign That by Norman O'Brown ahead of Synergetics. I point to the remoteness of the Synergetics vocabulary, which I don't know if we ever ended up finding. Let's try one more time. Let's see. And the idea that, the Earth will be a planet in 3 million years. If we're looking back on a successful run of shows, you could call them, if we've really done a good scenario for the next 3 million years, and we're proud of it looking back, then I'd say we're a star planet, right? Whatever that means. But I don't think our language, and we may be a mentor by then to future civilizations on other planets, maybe, I don't know. Sending probes, whatever we're going to do. But it's not language that we have now. It's like the far, far future, I don't believe, can be expressed in literal language because we just don't have the concepts. So I don't think we should force, when Bucky gets really out there, I think we should just see that as gas phase, right? It's like he believed in a lot of, he was very open-minded, and he used this language to look for, let me try another approach. Let me just go out to Google and try remoteness of Synergetics vocabulary, because I've written about it enough that it might pull up something of mine. Remoteness of Synergetics vocabulary. And this is the idea of a namespace. This is important for the future of freedom. and that we don't think that we're narrowing it to this one literal truth and that we can't create new languages, right? I think in philosophy, this is where we plant the trees of the future, and some of them are going to be, okay, so it's 250.30 that we're looking for. 250.30, and then we'll stop. 250.30. Remoteness of the Synergetics vocabulary. So I'm not going to read it out loud, and I've been here before, but I would come here and then I would go to a passage where he talks about all truth is semi-metaphorical verities, because his general principles cannot be expressed literally, because to literalize is the special case. It's to bring it down to one example, and then you're not talking eternal anymore. And so to put it into words, you've almost dumbed it down. In fact, that's a good way to put it. Special case is generalized principles for dummies. And we're really doomed to live in the special case and think in the special case. But we have glimmerings. We have glimmerings of generalized principles, which are like, in a way, too instantaneous to ever get into time, you could say. So that kind of talk, right? It's philosophy. And it's enough for me that Synergetics be used as kind of a switchboard, interdisciplinary cross-wiring pattern, so that you can, it'll help you jump quickly and work out in your right brain, get your imagination going. But it's not about dominating your all your thoughts so that you're only able to think in these terms or something. It's about jumping in and out of a namespace, okay, and using a Wittgenstein approach to explore what things mean based on how they're used, like precession. It's very interesting. We'll talk more about it. We'll talk more about Derek too. All right, I haven't gotten to that yet. Also, in the last video, could have raised some questions because of how I use C60, which is the chemical term, carbon 60, interchangeably, it seems, with C60, which is spelled like this, right? This is the product C6XTY. So think of something more like ecstasy or something. Not the drug necessarily, but the mental state perhaps. Just to keep the two separate. You'll see, again, that's in the video track, I'll catch errors and I'll put little thought balloons. So sometimes I'll say something wrong. Like I talked about the game of life on a hexapent and how some of the cells are surrounded by 6 other cells and others by 4, whereas I should have said 5. I corrected that, but on the video track only. Just wanted to remind you, I make a lot of mistakes. Try to catch some of them. Can't get them all. Talk to you soon.